Hi, this is Jay again. Now I'd like to demonstrate how to use this system dynamic graphical user interface. We'll see basically how the aquifer elevation, water level, will change when we implement some management options, such as groundwater containment and surface water conservation activities. Okay, so this model basically monthly time step starting 1980, May 1980 to October 2008. So when you look at this groundwater elevation, this is a historical groundwater elevation, again starting May 1980 through October 2008. As you can see, groundwater elevation gradually decrease over time. So if we do nothing, so there is no bright future in state of Idaho because all water resource in the Eastern Snake Plain Aquifer will dry up. Okay, so let me reset this model. If you click the restore all button, just click this one, and the graph is gone, and it's very clean graphical interface, right? And let's just click the run model. Basically, we just run this model using default value, basically, which means we just plug all the information from ESPA model and plug it into the system dynamics model, and then run the model. As you can see, groundwater elevation indicate gradually decrease over time, right? So again, if we do nothing, there is no future in the state of Idaho because all water in Eastern Snake Plain Aquifer will gone, dry up, right? So we have to do something. So as you can notice, IDWR, state agency, water department put the effort and develop model and calibrate the model, Eastern Snake Plain Aquifer model, which is ground-based, mud flow-based groundwater model. So we use that model for many years in the past. So basically, we plug in the outcome from the ESPA model into the system dynamics model to better communicate between the two parties, right? As I said, water resource scientists and engineer and policymaker and decision makers, okay? So they will be excellent communication tool to better communicate between two parties, okay? So to do something to make the situation better, we can consider some management option are listed in CAMP document, comprehensive aquifer management document, published in back in 2017, maybe 15 by Idaho State Water Board. The ground curtailment option, that is one of management option, and also surface water conservation option. Of course, there are many more, like managed recharge and crop rotation and cloud seeding program and so on, right? But in this practice, I simply incorporate two options: groundwater curtailment and surface water conservation activity. Okay. So again, if we do nothing, the graph it looks like this. There is no water near future, so we have to do something. First, let me try to incorporate groundwater curtailment by 5%. So groundwater irrigator curtail the water resource groundwater pumping 5%, and we'll see how it happen in the groundwater level. Just click groundwater curtailment 5% and click run model. The situation a little bit better, right? As you can see, this red graph, dotted red graph, indicate groundwater elevation. The situation is a little bit better. If we increase curtailment level by 10%, what will happen? Again, click this button and run model, and the situation is better, right? and then you can try to push a little bit harder, and groundwater irrigator want to curtail their water pumping by 15% and see how the model respond. See, the situation is very looks nice in the sense that the graph pretty much is stabilized up and down, up and down. So economic term, it is equilibrium, and the water resource community, this situation called the status quo condition, and so on, something like that. I really want to see the aquifer water elevation shape like this, up and down, up and down, up and down, but still it's pretty much stabilized over time, right? I'd like to see this kind of result, okay? So again, let's reset your model, and this time we can do a little bit different approach. So although the first test, actually groundwater irrigator and jump in, and they just actually sacrifice, basically because they curtail their groundwater pumping in different range, right? In this time, we can just ask surface water irrigator, why don't surface irrigator actually put some effort in their surface water conservation activity. So again, if we just run with the default value, the graph indicate groundwater level gradually decrease over time. But if surface water irrigator actually put their effort to make this situation better, for example, they want to put some surface water conservation activity to 2% surface water conservation activity, we'll see how the model actually responded to their action, right? And then situation is a little bit better. And then surface water irrigator put more effort to conserve a water resource in this area. How those action actually contributing water resource availability in this area. And click run, you can see, as you can see, the situation getting better again, right? If you if they put the more effort to conserve water resource in this area, what's going to happen? See, again, the graph is very close to steady, steady state trend, right? Like that. So this is another example, right? So let's reset your model again, and this time let's demonstrate. Let's demonstrate how joint effort put in place, how those action contributing water resource availability in Eastern Snake Plain Aquifer. So now your model is reset, okay? And then just run the model again. The groundwater elevation gradually decrease over time, but now both surface irrigator and groundwater irrigator put effort to manage water resource in this area. So for example, groundwater irrigator actually implement their curtailment option by 10%. At the same time, surface water irrigator wanted to sacrifice, their water usage through the surface water conservation activity by 2%, for example. And then you can just click the run. As you can see, the groundwater elevation pretty much steady state status, right? So this is basic exercise to explore some management option and solution down the road, by working together. If there is some still conflict is visible, we can put effort to find out the trade-off among our water users. Additionally, if climate change issue is also in big challenge down the road in the future, we can also implement some climate change option in here. Okay, so with that, that's all, and you can play around with this example, and if you have a question and comment, just shoot me email, and of course we can upgrade this graphical user interface, and also we plan to incorporate additional data set from next level, next version of ESPA model, Eastern Snake Plain Aquifer model, from the IDWR. And now it's your turn, and stay tuned. Thank you.